Thanks for listening to the STEM Factually podcast. I'm Dr. Marissa Civic, and today I'm going to discuss part 2 of how to assess the validity of STEM research articles. So hopefully you've listened to part 1. In part 1, we really talk about how to assess validity, and in the second part, we talk about how to read an article, understand the article, find the information that you're looking for in the article, and how to get the most out of your reading experience. So this is an important component of the process. Once you've assessed that the paper is a valid potential resource, now we need to read the article and continue to ensure its validity, but then also hopefully get the answers that we were looking for in the first place. So this is geared towards anyone who would read a research article, which can be high schoolers, undergraduate students, graduate students, even the general public, and anyone that's still has questions about how to do this. So hopefully this is helpful. All right, so I'm going to dive right in here with some tips for the process. So first, I really recommend reading the whole paper. A lot of readers will just scan parts that they find relevant. That's really a skill that takes years to develop to determine what components of the paper you would need to read or eliminate from your reading process. I typically read the whole paper unless it's a field that I'm very familiar with and I don't necessarily need to read like the introduction or something like that. But yeah, so I recommend reading the whole paper. It takes a while, so definitely give yourself some time, and you can do it in sections, but I have some tips for how to break it up when you're doing the process that I'll talk about in a bit. Something else that just to keep in mind, know your limitations. Everyone who reads a research article comes from different backgrounds and has a different set of skills and expertise. And the authors of the paper are typically in a very niche field and are experts in their niche. So even though you may be an expert in the field of chemistry, for example, you may not be an expert in this particular specific subset of organic chemistry that you're reading about in a paper, for example. So, STEM's a big field. Know your limitations. Know that you may misinterpret the paper or you may not understand something. So don't go into the paper like cocky and overconfident. Just accept that you may not understand every word and that you're going to have to read it multiple times and give it the time that it needs for you to understand and process the information. Another tip is to take notes throughout the process. You can do that with your hands and a piece of paper, or you can do that digitally. I used to use a reference manager. You can just Google those. They vary in popularity. Every couple of years, a new one comes out and it's more popular than the last. Doesn't matter what one you use, but a reference manager, for those listeners that aren't aware, is a software that you can download or use online that saves papers and other PDFs reference in a reference format. And you can also save notes and things like that alongside the PDF or the link or the citation. So they're very useful when you're reading through many different papers. When I was in grad school and as a professor especially, I had everything saved immediately to my reference manager, and I would make short notes and a brief synopsis of whatever I read so that I could easily refer back to that. And you can use tags and things like that, so it's easy to find what you're looking for and not read the same paper over and over again accidentally because you're tired and forgot that you read it. So with that, I recommend writing a summary of each section that you can refer back to later. If you're very versed in reading literature, you're probably not listening to this, but if you are feeling confident and you've read some papers and things like that, then you can usually just write a summary at the end of the paper. If you're new to reading literature, then I recommend that you write a summary after you read each section so that you can refer back to your summary throughout the reading process of the paper. It's very helpful. Let's see. Don't draw conclusions from the paper that the authors did not. If authors can make a claim, based upon their data, they will include it in the paper. So one of the biggest ways I see misinformation spread now is news articles will take a research article, and then someone who's not familiar with the field, some kind of author, will read the paper and then draw some major conclusion. I'm sure that everyone listening has seen that before. It's, a research article will publish something saying that a particular food could be linked to disease, and then a news article picks it up and says, oh, this food causes this disease. And that's not what the author was writing. That was not the implication of the article. So don't use research articles to support some kind of misinformation or agenda, either on purpose or accidentally. And often it's accidentally that this occurs. People don't respect that they have their own limitations when they're reading the paper. They think that because they've looked it up and read it, that they can be confident they know what they're talking about. But it's really important to not draw any conclusions that the authors did not make themselves. It is never implied in a research article if there's a conclusion that can be drawn that is definitively supported by data. So take that and process it and make sure that you apply it throughout your reading process, especially if you're going to relay the information to someone else via a social media platform or in a position of authority where people will believe what you're saying. So don't take things out of context. All right. Also, make sure you carefully examine the data. When you're reading papers, it's very easy to just look at the figures. A lot of students that I've worked with can be drawn to the figures, and then they draw their own conclusions from the figures. Don't do that. Don't take a figure out of context and then use it to support data or something like that. You want to make sure that the figures are contained within context of the paper, and the only conclusions that you're drawing from those figures are the ones that the authors have also drawn from those figures. So make sure that you carefully examine data, you read what the authors resulted from that data, and then do not take the information out of context and draw your own conclusions. Whenever you're reading a paper, always keep an eye out for red flags. It's very difficult for me to list the types of red flags because there's just so many different types, especially dependent upon the field. But something for like medical studies, for example, if you're looking at a small population of people, let's say they did a study on a sample size of 10. So 10 people were examined for whatever, and they got these results and they analyzed them. They can't really make any kind of conclusions based upon that because they're so limited in their population. There's too many external variables, and those external variables can't be countered or considered or washed out with a statistical representation, a large population. So that's something to consider when you're reading. That research can still be valid, but it's definitely more of a starting point for more research versus a strong, conclusive set of evidence for any kind of conclusion we could draw from their implications. Take breaks. So reading a research paper, they are extremely dense. It is not easy. Even as a PhD chemist, it takes me a good amount of time to read an article in its entirety, even if it's within my specific field. If I want to read it and get the information that the authors were trying to relay out of it and process it and be able to apply it to my own perspective, or my research back when I was in research, then it took me quite a while, sometimes an hour, to really sit and read the paper thoroughly. So if you're not an expert, then it could take longer, and it really just, you'll get more used to it as you read papers. Students could take an entire day to read a paper, so it's really good to break it up and write summaries and then go back to them. Okay. I talked about being careful relaying what you read. Do not exaggerate or make claims that were not made by the authors, and don't draw your own conclusions. They should be laid out by authors, and if they're not, then there wasn't enough data to support making those conclusions. So it means that they might not be true. Okay, so when you first get your paper, you can read them on a computer, you can print them out. Sometimes I like to print them out. I try not to do it too much to save paper, but I will sometimes use my tablet to draw on them. I like to be able to mark up the paper as I read so that I can underline and circle citations and things like that. But you can read it in any order you want or any format, but I recommend just reading it as it's written. I start with the abstract, so I'm going to just follow the process I would follow when I read it. So to talk a bit about the abstract, I've already talked about what an abstract is in part 1. So if you're not familiar with the parts of a paper, go back and listen to part 1, and I talk about what each section is and what they mean and all that. But basically, an abstract is a summary of the whole paper, and it includes the major results, usually in the end of it. And they're pretty short and quick to read, and they're great for determining if the paper is worth reading and you need more information. So it's a good way to parse through literature. So I really read the abstract thoroughly, and I try to repeat it back to myself as a summary. I type up a brief summary and the take-home key points, and then that tells me whether or not the rest of the article is going to have the information that I'm looking for or not, in all likelihood. So there's not much to it. Just don't just read an abstract and then take that information and go relay it. The abstract is really to give you a summary of what's within the paper. Is the paper worth reading in its entirety, or should you skip it and pick another paper? That's the purpose of an abstract. They're also usually open access. I've never seen an abstract behind a paywall. So the point is that it tells you what's in the paper so that you can determine whether or not you should find a way to obtain the paper. So then I go right into the introduction. I recommend reading the introduction very slowly and repeating paragraphs if you need to. Sometimes it's helpful if you're reading something if you perhaps don't have a degree in the field that you're reading. I sometimes recommend reading it out loud. Sometimes hearing it and hearing yourself say the words and having to verbalize them is helpful when you're learning something new. So that can be a helpful tip. But intros are usually written in a way that they can encapsulate a larger audience, and they also give you background on the project that's relevant or interesting, sometimes a history of what's been done before, and they're kind of easy to grasp for people who are maybe not experts in the field that the paper is in. I always recommend reading them, and often students will skip them and just hop to the results to get the data they need. But I think that introductions are really beneficial for growth, educational growth when you're reading, because you really get a better familiarity with the field. So while you're reading, you have to kind of figure out what's actually relevant and what's a history to just give you better scope. And I always recommend marking down any terms that you're not familiar with. There are usually a considerable number of citations in the introduction, which can be very helpful as well. You can immediately add them to your reference manager and look them up later to read, tag them as unread, and then it's kind of helpful because it's related directly to the topic that you're exploring, and it gives a nice history and background of what the project is. Definitely put notes for terms that you think are relevant, and you can always take a break after the introduction. I always recommend, if you're going to take a break, especially make sure you write a brief summary of what you've read and how it's relevant to the question that you're asking, or perhaps you're gathering literature for a literature presentation or a publication. It's a nice way to write a quick summary so you can refer back and give your brain a break and read more later. So sometimes the materials and methods is next. The order of paper always varies depending upon the journal and the author. So how you approach the material and methods really depends on your background as well as your goals for understanding the article. If you're using the paper for a literature talk or a publication or something like that, you would definitely want to, at a minimum, scan the materials and methods. Look for red flags. What kind of instrumentation were they using? Is this instrumental method actually effective for what they were measuring? Was the population too small that they used? Or how did they do their analysis? Sometimes you'll see hidden in there that a lot of the paper is actually computationally predicted. So it's not based on empirical data. They did a statistical analysis on a small amount of data and then extrapolated that data to get the remaining results. So there's a lot of information that's not hidden, but that's in materials and methods that you as a reader would need to parse through. And it can be very difficult to do that if you're not in the field. So if you're listening to this and you're in the general public category, that the materials and method can be a good place to spot red flags or not. And I don't mean to say that these papers are done in a bad way, but it's a red flag in that it's not a good representation of what perhaps you're trying to draw from the paper. So if you're looking for very definitive data on a particular topic, and this is just a theoretical study without any physical data, then it can be tricky if the topic that you're looking for needs a physical aspect. So that's something that you need to kind of go through, skim, and make sure that there's no blaring red flag if you're the general public. If you have a background in STEM and you're reading a paper that's relevant to something like a publication or a literature article, then you would need to examine that section pretty thoroughly and make sure that their methods and materials are all legitimate and valid, and that if they are legitimate and valid, that they're actually applicable to what the conclusion is you're trying to draw from the paper. So it's kind of tricky. A lot of information in there, and it's mostly technical. So if you're generally looking, then look for the big ones that are easy to understand. Population sizes. Sometimes they incorporate limitations. Sometimes other little bits of information that you'll want to know and determine whether or not the article is reliable as a resource in general and for your particular question. It is a great place, though, if you're interested in exploring a field and the different techniques that are used. I like to read the materials and methods sometimes just for fun on different papers to see what's being used right now, or like what kind of resources a particular university has. There's like a wealth of information in there that's really useful for undergraduates and graduate students as well. So don't skip it. Take a look at it, but know what your goal is for the overall paper, and then apply that to the way that you read the materials and methods. All right, so next up is results and discussion. Results and discussion are sometimes split into multiple sections. So you may have a results and discussion. You may have a results with a separate discussion. And sometimes they'll call it other things. So whatever it is, I'm going to clump them together. I like when it's all personal preference, but I like when papers clump them together so that I can see the results and then also see right after what the authors are discussing and how they interpret the data. So it's not easy to skip over the figures or just look at the figures. You're getting them both together in a nice cohesive way. The R&D is also the most dense section of the article and usually contains the information that most readers are looking for when they're searching for a literature paper. But it's not easy to read an R&D. It's definitely doable, but it takes time and focus and skill. So it's something that you have to practice often. And when you're reading it, there's a lot of nuance as well that you may not pick up on unless you're familiar with STEM. So it's something that you'll learn as you're reading more. The nuance, you'll develop the skills to understand the material a little better, and you'll start finding that the R&D isn't quite as dense and unapproachable the more of them you read. The figures can be difficult as well. Even if you are an expert in the field, you really have to focus on the figures, read the legends, examine carefully the graphs and figures, and then try not to draw your own conclusions from them. Go to what the authors are saying, read what they're saying, and then examine the figures carefully again. So there's a lot of reading, looking at data, reading what the authors say, going back, looking at the data again, seeing if you can see what the authors see, looking for little red flags throughout the data that it's perhaps not an applicable article to what you're doing. So it's a lot of reading and rereading sections and dense material, and it takes a while, and I recommend taking notes. So I already mentioned not to take figures out of context. Don't just take a figure and slap it in a PowerPoint to use it as supporting data for something you're doing. Make sure that you carefully look at the figures, carefully read what the authors say, and then determine if that figure is relevant to your arguments with regards to your own research or the question that you've asked. Something I like to do as well is see if once I read what the authors say they gathered from their data, I go back and look at the figures myself and see if I can draw that same conclusion. So make sure that they interpreted the data correctly and that I understand how they interpreted the data. Don't just take their word for it. Look at the figures, draw your own conclusions once you've read what theirs are, and confirm that they're matching. When you're done with the R&D, it's very important to pause and write a brief summary of what you've read and learned. You can throw that in your reference manager or take notes in a journal, whatever works for you best. So the next section would be the conclusions. A lot of people skip conclusions. I don't recommend skipping any part of the article, but I actually find the conclusions quite valuable. It not only summarizes the major points of the paper, but it also gives an interesting idea of where you could go with the research. So how the research adds to the current literature and what's next. And I always think it's fun to see what's next. And then you can look at the section in the journal that says who has cited that paper, and sometimes you can get questions that were put in the conclusions answered by other researchers that have now done what was in the conclusions and have cited the conclusions. So it's kind of a very short, brief section that's easy to read and has a good take-home message as well as a future goals kind of perspective. So definitely worth reading and then relating back to what you've already learned. And it's kind of a small section, so it doesn't usually need notes. But if there's something interesting you see in it, it's great to add that to your summary. So there's other sections to a paper as well. There's the acknowledgments section, which is usually brief and small, and it just acknowledges anyone that contributed in some way that wasn't large enough to warrant an authorship. I usually look because sometimes there's conflicts of interest in the acknowledgments, so I just take a peek at that to see if there's anything that looks out of place. There's also the supporting information on some papers. Supporting information is usually open access, so you have to go back to the journal and just click the little supporting information, and then it pops up a PDF typically. It's usually just any extra data that goes with the paper and supports the conclusions, but isn't really excessive or not necessary for the primary components of the journal. So they put it as supporting information. It's there for your reference, but it's not necessarily needed to get the take-home message of the article. I typically scan them if I'm in a deep dive of a paper. If I'm just looking for a quick answer to a question, then I might not look at the supporting information. Citations, I typically scan citations. I talked in part 1 about why, mostly to examine the validity of the paper. You want a wealth of citations, not too many self-citations, just to get up the count. and you want them to be from valid resources as well. A paper that has 1,000 citations that are all from an unreliable resource is no longer a reliable resource. So it's important to look at that. And then it's also helpful to look at the cited by section. So see who cited the paper, where the research is going, and, kind of how impactful that the research is that you're looking at. Once you're done reading all the different components of the article, I recommend writing, I've said it a few times, a brief summary of the article, save it in the same folder or in the notes of your reference manager, take a break and don't look at it again for the day. Then, a day or two later, go back and reread it. It'll be much clearer to you the second time you read it. It'll cement the concepts you've already learned, as well as you'll pick up on the ones that you didn't pick up on the first time. And then you can update your summary. I actually recommend writing another summary. So you'll have a couple summaries, and each one should be better than the previous one. So I really think that pausing between reads is very important, as it gives your brain a break and you go back with a fresh set of eyes and you're able to understand the information better, as well as discuss it if you're giving a literature talk, for example. So, just to kind of reiterate, read the whole paper, know your limitations, take notes on the paper as you're going, as well as when you're done. Use some kind of reference manager to sort articles, and you can tag them with what kind of relevance they are. It's a great way to be organized with your literature. Write a summary of each of the sections that you can then refer back to later, and give your brain a break as you're reading different sections that are a lot dependent upon your background. Big one, don't draw conclusions that the authors did not, and make sure you carefully examine data and you do not take data out of context. Always keep an eye out for red flags when you're reading, as well as just any information that implies that the article isn't what you're looking for, or that it doesn't translate to what you're doing. So it's not worthwhile to finish reading the paper. It's better to go find another more relevant paper. So always have a critical perspective when you're reading papers, so that you're aware and you catch anything that's irrelevant to what you're looking for. And then, of course, just be really careful relaying what you read. Don't exaggerate or make claims that were not made by the authors. Don't take figures and use them to support things that they don't. Just make sure that you're ethical and you represent the paper that you've read in the way that it was intended to be represented, so that we really combat the amount of misinformation that's spread either maliciously or out of confusion. We just don't want to be a part of that. So the goal is to really carefully read the papers and then discuss them in a way that they are actually meaning to be discussed. So that's about it for the the different sections of a paper. It's kind of difficult to discuss this type of thing because every article is so different and every field is so different. So I'll probably do a series of episodes where I actually walk through the process of this with some kind of open access article that anybody can follow along with. So I'm going to work on that. It will take a little while to get that one ironed out because I want it to be really well done. But definitely thank you for listening to part 2. And if you listen to part 1 as well, I appreciate the support. If you have any questions, you can comment on these pod episodes, or you can contact me via social media. We're on Twitter as well as Instagram and Patreon. And I also have a website that there's an email box. So any questions, suggestions are much appreciated. Please follow the Spotify if you wouldn't mind. That would be great. And yeah, thank you. Have a great day.